Get ready to have your minds blown today, because we're diving headfirst into a research paper that could seriously shake up physics as we know it. Opportunities in flavor physics at the LHC and LHC. Catchy, right?
Well, it's about pushing the limits of what we know about the universe with these, well, insanely precise experiments. Imagine something so precise it makes splitting a hair 1,000 times look easy.
Okay, you've definitely got my attention, but before we get lost in the weeds, let's set the scene. We're talking about the Large Hadron Collider here, right? You know, that massive underground tunnel where scientists smash protons together at crazy speeds?
It's like, imagine trying to understand how a watch works. Not by carefully taking it apart, but by smashing two watches together at the speed of light and then studying the debris. That's kind of what we're doing with the LHC, trying to break matter down to its tiniest parts.
And this is where flavor physics comes into play, right?
Yeah.
It's like we're categorizing the tiniest building blocks of matter quarks by their, well, their flavors, their unique personalities, I guess you could say.
Precisely. We're talking about studying how these flavors interact, which helps us really put our understanding of particle physics, particularly the standard model, to the test.
The standard model, you mean, like the rule book of the universe?
That's one way to think about it, yeah. It's our best explanation so far, though it definitely has its gaps. And that's where these upgrades come in the HLLHC and HELHC. They're designed to, really poke at those gaps with ridiculous precision.
So we're talking about next level precision here. The research paper mentions it constantly. What's an example of this mind-blowing precision?
Well, remember those flavor categories? Imagine a triangle where each side represents how they interact. That's the unitarity triangle. Now, this paper, it really digs into how the LHC upgrade will allow us to measure the sides of this triangle with a level of accuracy that, frankly, could turn our understanding on its head.
Hold on, so we're not just talking about making things clear. We're talking about potentially proving our current understanding is, well, wrong.
Exactly. Even the tiniest error could point to something groundbreaking, new particles, new forces, heck, maybe even new dimensions we never even thought of.
Okay, now this is starting to sound like a sci-fi movie. But seriously, how do you measure something that small? Something that exists for, what, a nanosecond?
See, that's the really cool part. These upgrades aren't just about energy. They're about improving the time resolution for measuring particle decays. We're talking about particles that exist for fractions of a second, and these upgrades will let us track their behavior with incredible accuracy.
It's like watching a movie in super, super slow motion, right? Capturing every single frame of a blink and you'll miss it moment. But why is this level of detail, this precision, so important? What are we hoping to find? It really is like entering a whole new world, this world of the unbelievably small, where time itself practically stands still. But what are we hoping to find with this level of precision? What are we looking for?
Well, that's where things get really interesting. You see, those gaps in the standard model we talked about. This research suggests these upgrades could actually help us answer some of the most fundamental questions we have about, well, about everything. Like, why is the universe mostly made of matter? Shouldn't there have been equal amounts of matter and antimatter, just kind of wiping each other out?
It's like the universe had this epic game of rock, paper, scissors, and matter just happened to win, leaving antimatter, well, basically extinct.
Exactly. And it's one of the biggest head scratchers in physics. But here's the thing. With the LHC getting this massive sensitivity boost, we might actually be able to find those subtle clues that explain, well, this whole matter-antimatter imbalance.
So we might finally solve the case of the missing antimatter. What other mysteries are on the LHC's most wanted list?
Well, another exciting prospect is the potential discovery of what we call superpartners. It's this idea that every particle we know of has this heavier, undiscovered twin, a superpartner. Finding them. Now, that would be, well, revolutionary is an understatement.
So, like, we're about to discover a whole secret family of particles. A whole new branch on the particle family tree. Wow. What would these new particles tell us about the universe?
That's the million-dollar question. Their existence could potentially explain some of the biggest mysteries we've been grappling with, things like dark matter, the hierarchy problem. It wouldn't just be about adding a few new particles to the mix. It'd be about rethinking our whole understanding of how the universe works at its core.
Okay, so we've got the missing antimatter case, the potential for discovering superpartners. What else?
Well, the paper also explores a pretty wild concept, what they call lepton flavor violation.
Leptin flavor violation. Okay, now you're just messing with me. What even is that?
Okay, so leptons are these elementary particles like electrons. Now, the standard model, it has these very specific rules about how leptons can change, how they interact, rather.
So there's like a set of rules these particles have to follow, a leptin code of conduct.
Yeah, basically. And lepton flavor violation would be like witnessing those rules being completely broken. Like, imagine an electron suddenly transforming into something totally unexpected.
Talk about a plot twist. What would that kind of discovery mean?
It would be huge. It would absolutely point to physics beyond the standard model, new particles, new forces, heck, even new fundamental interactions we haven't even begun to consider.
This is wild. These possibilities are, wow, they're mind-blowing. But I have to ask, with all this talk of particles and forces we can barely wrap our heads around, why should the average person even care about these discoveries? How does it affect our lives? It's easy to get lost in the world of quarks and leptons, but it seems like what we're really talking about here is, well, the essence of reality, right? So how does understanding these mysteries, these tiny particles, how does that impact us in the real world?
I love that question because it really gets at the heart of why particle physics matters. It's easy to think of it as this, oh, it's this very abstract thing, completely removed from our daily lives. But the reality is, it has this incredible track record of leading to advancements that impact, well, all of us.
Okay, give me an example. What kind of advancements?
Think about the World Wide Web. It was born at CERN, the same place as the LHC.
Yeah.
The technology that comes out of particle physics research often finds its way into other fields, sometimes in ways we never could have imagined.
It's true. Knowledge has a funny way of coming back around. Who knows what these LHC upgrades might lead to?
Exactly. And beyond the cool technology of these experiments, they have the potential to completely revolutionize how we understand the universe. These are the big questions we're talking about here, the really big ones. Like, where did we come from? What is the universe even made of? What are the rules that govern it all?
It's like we're piecing together the universe's origin story, starting with the absolute smallest clues possible.
That's a great way to put it. And the amazing thing about science is that every answer usually just leads to more questions. It expands our understanding, pushes us further into the unknown.
So as we wrap up here, what's the one big takeaway you want our listeners to walk away with today?
This research paper, it really highlights the power of precision. It's about looking for the smallest discrepancies, those little anomalies, those tiny things that everyone else might overlook. Because those tiny things, they might just hold the key to unlocking the universe's biggest secrets.
It's almost a metaphor for life, isn't it? Sometimes the greatest discoveries come from paying attention to the smallest details.
Absolutely. And I think as we delve deeper into this world of particle physics with these LHC upgrades, it's a great reminder for all of us to approach the world with a sense of, I don't know, a sense of curiosity, a sense of wonder. Because who knows what incredible discoveries are out there just waiting to be found, right?
What a great point to end on. A huge thank you to you for taking us on this incredible journey into the future of particle physics. It's been a wild ride.
It was my pleasure.
And to our listeners, thanks for joining us on this deep dive. We'll see you next time.